We propose a new personalized face inpainting algorithm that requires less reference images and fine-tuning for each new identity. We also propose a new dataset for benchmarking identity-preserving face inpainting tasks. Personalized face inpainting is the task of filling the missing parts of the face while ensuring the identity remains the same. The identity information is usually specified by a few given reference images. Existing approaches like MyStyle requires at least 40 images and 15 minutes to fine-tune. Reducing the number of reference images results in artifacts. Another recent diffusion model-based technique, paint by example, fails to achieve good identity similarity. On the other hand, our method is not only able to generate images of good identity similarity, but also allow control over the inpainted region, such as having beard and different expressions. We also propose a new benchmark for evaluating the identity-preserving image inpainting task. Now we introduce our method, Parallel Visual Attention, or PVA for short. Our method is built on top of diffusion models. We take a pre-trained latent diffusion model as is, freezing its parameters throughout the training and inference. We only train PVA modules, which takes the language prompt and several reference images as input, and interact with the diffusion model by cross-attention. For each new identity, PVA only need to be fine-tuned for 40 steps, which costs less than 1 minute. With the help of PVA modules, diffusion model is able to recreate the identity of the person. Now we explain the architecture of PVA in detail. PVA pathway consists of an image encoder and PVA modules. The image encoder first processes the reference images using a domain-specific model pre-trained on face data, which is arc face in our experiment. The features are then aggregated by a transformer module to be a fixed-length visual embedding. This allows the model to take different number of reference images, eliminating the need to train different networks for different number of inputs. The PVA modules are modified from the cross-attention modules in diffusion model by introducing a new set of attention matrices Q', K', and V', which only attends to the visual embedding. We train the PVA module on the proposed CelebAHQ-IDI dataset. It is built on top of the well-known CelebAHQ dataset using its identity annotation. The dataset is organized according to the number of images per identity. The dataset we use in the experiment is CelebAHQ-IDI 5, which means each identity has 5 reference images, and the rest are inference images. We have approximately 1-to-1 ratio for reference and inference on this set. One exemplar identity of this dataset is shown on the right. Now we present experiment results. Compared to 5 baselines, latent diffusion inpainting, paint by example, textual inversion, and custom diffusion. We conducted evaluation on the test set of CelebAHQ-IDI 5. Results shows that our method achieved the best identity similarity and a high image fidelity. Moreover, we only needed 1 minute of fine-tuning. We also compared the language controllability. We run inpainting on the large random mask with 15 prompts, covering expressions, actions, etc. Results shows that our method is able to achieve the highest identity similarities with a clip score close to textual inversion and custom diffusion with guidance scale 1. Now we present some qualitative results on identity-preserving inpainting. The method from left to right are latent diffusion inpainting, paint by example, MyStyle, textual inversion, custom diffusion, and our method. The red numbers are the identity similarity to the ground truth. Here is another set of results. Audiences are encouraged to pause and take a close look. Here we show some qualitative results on language-controlled identity-preserving inpainting. The green numbers are the clip score. Thank you for listening.